Good morning, all. Hope my voice is audible to all the participants. Okay. Thank you, Madhukar, sir. Uh,
Just a minute, sir.
okay, sir. Okay.
Abhishek, I think you are on the meeting, right?
Yes, Madhukar. Yeah,
Yeah, I think it's good to go, right?
yeah. We can start right now.
Yeah. So I welcome all members for the day six. Now I hand over to Sumit sir for the introduction of the speakers. Thanks. Sumit sir, good to go.
Thank you, sir. Madhukar, sir, for warm welcome. Good morning to each and everybody. Warm welcome to all the participants on the fifth day of our faculty development program. As we approach the final stretch, I hope you are feeling energized and motivated to make the most of these last few days. Today, we'll dive deeper into a topic, and I'm excited to see the connections and insights that will be emerging. Let's continue to engage, learn, and grow together. Wishing you all a productive and a fulfilling day ahead. And also feel free to modify it to fit your program's tone and style. Today, we have our chief guest, Mr. Abhishek, who is a chartered engineer. We talk about the Abhishek sir. He is a certified chartered engineer from IMechE UK and assistant manager in the research and development department in Kirloskar Pneumatic Company Limited and a research scholar at the University of London. His doctoral research focused on developing a framework for modeling and analyzing of multi-stage creep compressors, combining advanced techniques such as machine learning, design of experiments, and Bayesian optimizations. He developed frameworks using Python, TensorFlow, and MATLAB with practical experience on GT Suite and SCOG software tools. His academic achievements include a Master of Technology in Mechanical Engineering from Indian Institute of Technology with the highest grades and Bachelor of Engineering in Mechanical Engineering from Vishweshwara Technological University. He also has a Six Sigma Green and Black Belt Lean Management Professional and Project Management Professional certification from MSME Government of India. He is a mathematics expert with full marks in all parts of English, Mathematics 1, 2, 3, and 4 during the bachelor's. The Central Board of Secondary Education has also awarded him for scoring full marks in mathematics during his secondary and higher secondary educations. Additionally, he has an excellent communication skills and scored well at GATE exams in a mechanical paper. We welcome Mr. Abhishek, sir. The session is all yours. Hello.
Hello. Hi, Madhukar. I'm not able to share my screen. Could you please give me the access to it?
Sure. Just 1 second, sir.
Yes.
Okay, please just one check it out, sir.
Yes, sure. Okay. My screen is visible to all.
Yes, sir. Yes, it's visible now.
Okay. Yeah. So I'll start now. First of all, good morning, everyone. My name is Dr. Abhishek Kumar, and I did my PhD in screw compressor from City University of London, and I'm also an assistant manager at Kirloskar Pneumatic. So I'm very delighted to be here with you today for this exciting session on AI/ML approaches in medical additive manufacturing, where we'll be focusing on some case studies, on real life case studies in mechanical domain, that too particularly in the manufacturing part. And in this session, we'll also explore some AI and machine learning, not only for manufacturing, but also for how it is personalizing medicine layer by layer. So without further delay, let's get started with the presentation. Here's an overview of the topics I'll be covering. Like first, we'll explore why artificial intelligence is important and understand what truly AI is. Next, we'll look at some real-world case studies of how AI application has been applied to different machine learning applications in manufacturing industries. And lastly, we'll also see some AI opportunities in medical additive manufacturing. Finally, we'll conclude by some key takeaways, and then we'll open up the floor for the question and answer session in the end. So let's begin by understanding why artificial intelligence is becoming such a transforming force in industries today. So if you look at this figure one on the right hand side, this is a picture which is pointing the Moore's law chart. It states that if you see this on Moore's law, you can see the number of transistors that is on a microchip that is doubling approximately every 2 years. And that is why the cost of computing is becoming half. So when the cost of computing is becoming half, there is a rapid growth in the exponential data growth, which leads to, we can say that it generates a vast amounts of data from connected devices, sensors, and digital interactions. This explosion of data provides AI with the fuel, because we all know the fuel to AI model is the data. So when when we talk about why artificial intelligence is important, it's bring an competitive edge. Companies which are leveraging AI can automate process, improve decision making, and deliver innovative solutions. It also increases the efficiency and cost savings. And one of the most important part in mechanical or manufacturing domain is that AI is the foundational pillar of Industry 4.0, the ongoing revolution of smart manufacturing and digital transformation. So this is the reason why artificial intelligence is important. Now, before moving to some case studies, we'll see what actually artificial intelligence is. So artificial intelligence is basically the simulation of human intelligence processes by machines, particularly computer systems. And when we talk about the components of AI, so it includes your machine learning, natural language processing, computer vision, and deep learning. These subsets of AI focus on specific aspects like learning from data or interpreting language and visuals. So when you look at this left-hand side flowchart, here you will see how AI integrates into decision-making workflows. Machines take inputs like big data and AI-generated possible actions. However, some people might think like AI will replace humans, but that is not the case. AI does not entirely replace humans. Human judgment is critical in evaluating AI recommendations, especially for strategic business decision. So this flowchart symbolizes it shows basically a symbiosis between AI and human intelligence is what leads to optimal business outcomes. So till now we understood why artificial intelligence is important and what actually artificial intelligence is. But what about the market study? So if you see this global market study of AIs, you'll see that in 2024, the market size is projected around $638 billion, while in 2034, it is expected to grow at a CAGR of 19.5%. So this chart is basically showing your total addressable market, that is your TAM for AI. It includes the combination of your AI software, AI hardware, and AI services. So when the market is so huge, we need to adapt with AI and include AI in our day-to-day work. So one famous computer scientist also said that artificial intelligence is the new electricity. So with that, we'll proceed with some case studies from real-life examples of manufacturing industries. So starting with the first applications, what we have implemented in Kirloskar. So we have made a performance predictions tool of compressor. Generally, when we talk about in compressors, like most of us, in layman language, if you understand that in compressor, basically we predict the performance. And what I mean when I say performance, it is basically your power consumption and the flow rate, which is required for the customer. And right now, that we used to calculate using the conventional energy equations and solving the mass continuity equations by solving the differential equation using RK fourth order method. So that was a time consuming process, and we need to obtain some license from the other industries. So we developed an in-house tool using AI, and we'll see how it predict the performance. So first of all, the performance parameters customers which are interested in are your power, flow, and efficiency. And through this, also they also need to understand like what is the best compressor size according to their requirement. For example, for better understanding, if you go to buy a air conditioning in a shop, you will generally ask for the tons of refrigerations. So the tons of refrigeration is nothing basically your coefficient of performance of the air conditioning. So in terms of compressor, the performance parameter is your power and flow. So when you specify your power and flow, based on that, the customer representative will tell you which is the best compressors, which is the best air conditioning suitable for you. Same is the case for compressor in this scenario. So these were the performance parameters, and the current limitations why we switched for AI ML is that dependency on third-party software, because we need to pay a hefty amount for the license renewal every year. It is a time-consuming process, and it does not have a lack of optimization scope. So that is why we implemented AI ML over here. The advantage which it gives is like your faster computational time, open source flexibility, because we have developed this AI in Python. So it is an open source software, and it also has the optimization capabilities using some of the machine learning optimization algorithms. So for example, I have shown here a data which is generated from one size of compressor from Kirloskar. And if you'll see that, as in the first slide I have mentioned, data is the fuel to AI. So as you go on increasing the data, you will see that this the mean square error. So mean square is net error is nothing but your performance metrics of machine learning model. If you want to judge how good your machine learning model is, we need to check some of the performance metrics. Like there are R square, there is a root mean square error, and here we have shown the mean square error. So if you see that as we go on increasing the data, you'll find out that your mean square error is finally converging. And at a point at around 19,200 data points, you will see your mean square error has converged. So it shows that increasing data beyond this point doesn't affect your machine learning model. So through this, first of all, in the machine learning model, we tried to do the data curation. That is your data optimization part. We understood like for training one compressor model, we need actually around 19,200 data points. So once the data is finalized and filtered, we train the machine learning model. And after training, we tested it on the testing data, because the machine learning model accuracy depends on how well it performs on the testing data. So if you will see this true versus predicted power, you will see that it all lies on the 45-degree line. This shows that my machine learning model is performing well. For this example, I have considered the supervised machine learning, that is your Gaussian process regression model. There are other machine learning models as well, but as a comparative study of all the models, we found out that the GPR was performing well. So, and not only on the testing data, but we also tested our machine learning model performance in some extraterritorial region. If you see this graph, here is the boundary region which is indicated by the dotted line. So the left-hand side on the boundary region is your training and testing data, where the machine learning model is performing very well. And on the right-hand side, you will see it is your extraterritorial region, which the machine learning model has neither been trained nor been tested. It's completely unseen data. And if you see, it also falls within the 95% confidence interval. So once your machine learning model performs well on the testing data as well as on the extraterritorial region, you can confirm that this machine learning model has been validated and is now ready to be deployed. So this is one of our case study from our industry where we build a performance prediction tool for compressors. And this is how we build the GUI of it, so that every employee in the Kirloskar can use this tool and benefit out of it. Now, in the next slide, we'll see how AI is being applied in manufacturing. So over here, when we talk about the manufacturing, in manufacturing, AI is generally applied for, you can say, the process optimizations, predictive maintenance, robot collaboration, and also you can say the real-time monitoring and diagnostics. One of the recent trend is the digital twins, where we create the virtual replicas of physical systems, which allows simulation and optimization of manufacturing processes before implementation. Now coming to some examples, one of the famous compressor company worldwide is the Howden. So this Howden company have developed an augmented reality and predictive maintenance for screw compressors. So you will see this is their dashboard, which using the IoT data from the compressors, they do a predictive maintenance. You will see that they have done some plots and charts over here, which shows basically your power consumption, what is your frequency of the electricity, and then depending on that, it also does a predictive maintenance, like when your compressor is going to be failed, so that you can do a maintenance before it fails. So this is their app which is available on Play Store, where you can find the augmented reality application in compressors. So this was some of the applications of AI in manufacturing, but we'll also see other domains that can be related to your applications with the medical and IT manufacturing. So when you talk about the quality control, so quality control is used almost every sectors of industry, whether it is your manufacturing industries or whether it is your medical IT manufacturing industries. So as I mentioned in the first slide, that one of the components of AI is basically your computer vision. So using this computer vision, you can detect the defects, dimensional accuracy, assembly validations, what is the surface fin analysis, and the packaging inspections. So using these images and videos in real time, it analyzes all this. And the example over here is shown on the right hand side. If you see with the image classification types of AI, it is classifying which type of defects it is, like whether it is a class 2 defect, class 4 defects, and so on. So this is one of the example where computer vision, that is a subset of AI, enables machines to analyze visual data such as images and videos in real time. Moving ahead to other applications in supply chain management. So in supply chain management, AI is basically used by enabling smarter and data-driven decision making. It is basically used for the demand forecasting, like what will be the demand when using the historical data and market trends. Then it is used for the inventory optimization, where AI helps to manage inventory efficiently, reducing excess stock and minimizing shortages. Other applications of AI in supply chain management is your supplier management, where it enhances supplier relationship management by evaluating performance and ensuring timely deliveries. Other applications in supply chain management is your logistic and route optimizations, where AI determines the most efficient delivery routes, reducing your transportation cost and improving delivery times. And the last applications in supply chain management is your supply chain resilience, where AI identifies potential disruptions and suggests contingency plans to maintain business continuity. Some of the example over here which I have shown is the Amazon's AI delivery supply chain, where it uses AI to manage its global supply chain effectively. It AI enabled features such as demand forecasting, dynamic pricing, and route optimizations, and through this, it fulfills your timely delivery process. And here is how the supply chain management inventory dashboard looks like. So moving to another case studies, we'll see how AI is applied in other sectors, not only your quality control, manufacturing, or R&D, but we'll see some non-technical sectors, that is your human resource sector, how AI is applied in finance sector. So first with the AI in human resource sector, when you see this, first is your recruitment automation. One of the good example in AI in HR is your LinkedIn Talent Insights. Platforms like LinkedIn leverages AI to identify and recommend the best candidates based on skills and job requirements, reducing the recruitment cycle. Other example is your employee engagement, where some of the companies have their own chatbot to answer their policies. Like uh, previously, the employees basically used to read the policy document in PDF form, but now it is customized with the help of the chatbot. And this chatbot we have implemented in Kirloskar Pneumatic, where the people of or the employees of the KPCL just can talk with this chatbot and understand about what the policy is. Then other examples in human resources, your performance analysis, where a good example is your SAP success factors, which uses AI to track employee performance metrics, offering data-driven insights to optimize productivity and reward high performance. Moving to finance sector, So in finance, AI is basically used for fraud detections, where one of the good example is your PayPal company, which employs AI algorithms to detect unusual transaction patterns in real time, protecting customers from fraud. And other example is your financial forecasting, where it uses the predictive models, analyze historical financial data to anticipate future trends. And finally is your expense optimization. So a good example of expense optimization is the company known as Expensify. So it uses tools which uses which utilizes your spending data to suggest cost saving measures, generate reports, and ensure policy compliance. So till now we have covered your manufacturing, quality, supply chain management, human resource, and finance. We'll move on to the next sector, that is your sales. In sales, AI is basically used to analyze the customer insights. When we talk about customer insights, some companies like platforms such as HubSpot, which collects and analyze customer data, providing actionable insights to improve sales strategies. The other example here is your lead scoring and sales forecasting. And finally, coming to your AI in service sector, because in services also AI is being implemented by for the predictive customer support, automatic ticket subsystems, and chatbots for after sales support. And one of the good example is your Gendex. So this was all about from non-technical sectors. Now we'll see how AI is being applied in medical additive manufacturing. So when you talk about the AI applications or mostly the opportunities in medical additive manufacturing, so the key opportunities, because in additive manufacturing there are many steps. If you refer this flow charts, first of all you get the data from the patient, what is the parts which is to be replaced, and then you go for the additive manufacturing. So first of all, a design, you can find the opportunities such as design optimizations, where algorithms like generative design help create lattice structures with lightweight strength, that is your acetabular hip cups shown in this example. So this is basically your additive manufacturing part of your hip cup, which has been manufactured using the additive manufacturing. The other opportunities in medical additive manufacturing is your process parameter optimizations, where AI fine-tunes your build orientation, laser power, and scanning strategies for better part quality. Then next is your quality assurance and defect detections. So this you can relate with the previous example, what I have shown using the computer vision. Other opportunities is your predictive maintenance for additive manufacturing equipment, which ensures uptime of critical additive manufacturing systems by identifying failures before they occur. Finally, is your supply chain intelligence, optimizes spare part production and stock with AI. So the supply chain management is also can be related with the last slide on supply chain management applications in AI. And finally, this AI can be very useful in document in regulatory documentations and compliance. Some of the tools like natural language processing based tools can use to auto-generate compliance documents, that is FDA and CE approved, to speed up the approval timelines. So these are some of the opportunities where AI can be implemented in medical additive manufacturing. And this is also one of the example where you will see an implant used in for the human facial restoration has been generated using additive manufacturing. So in additive manufacturing, AI plays a vital role, not only for the printing, but also from the first stage like design optimization to the documentation part. Now, finally, concluding the slide, we'll see what are the key takeaways and way forward from this presentation. So first of all, we saw that from AI are unlocking new possibilities in medical additive manufacturing, starting from your generative design of implants to real-time process control, defect detections, and automated regulatory documentation. And also leveraging AI can drive design precision, reduce lead times, enhance patient outcomes, and enable a complete data-driven clinical and productive decisions. But when we go on applying this AI in any sector, whether it is a mechanical domain or medical sectors, so there are some challenges. And one of the most important challenges in AI is a fuel to AI, that is your data. So clinical data availability and the quality of data is very important in any machine learning model. Then this machine learning model should be validated, because since this is an critical applications of medical, so it should have been validated properly with regulatory compliance. Then there are some challenges like integrating of AI with existing CAD or IT manufacturing softwares. And then the person using this AI must also be skilled. So these are some of the critical challenges. Now, talking about the roadmap on how we can achieve this. So if you'll see that, first of all, identify the clinical or manufacturing pain points, start with some pilot projects, upskill your biomedical and IT manufacturing teams with the AI tools, and collaborate with some healthcare and AI startups. So implementing this roadmap in short can provide you a better IT manufacturing and with integrated with AI. So we'll conclude this presentation by saying AI is just not enhancing additive manufacturing, it's personalizing medicine one layer at a time. So I thank you all, and these are my references, and now we open up the floor for question and answer session. Hello.
Yes, sir.
Yes, Madhukar,
Yes.
yeah.
Yeah, yeah. Is yeah, you are completed, na, sir?
Yes.
Now I would like to request our participant if any questions need to ask to sir, please you can ask or you can text in the chat box. Okay, okay, dear participant. Now we move for the next session, that is vote of thanks. Before that, I would like to announce one thing. Today we are having validatory session of our 1 week FDP that will be informed in the chat box. So I request all the participants to attend our validatory session. Next, if any participant need to ask question, you can put the question in the chat box, or you can personally chat in the group WhatsApp group also. Okay. So I would like to extend my heartfelt vote of thanks to Dr. Abhishek Kumar, Assistant Manager at the Kirloskar Pneumatic Corporate Limited, for delivering an enlightening session on application of AI in mechanical engineering as part of our 1 week virtual national level faculty development program on the emerging trend in the medical additive manufacturing AI and machine learning approach. Thank you, sir. Your expertise and insight into the application of AI in mechanical engineering have broadened our understanding of this rapid evolving field. Your presentation has undoubtedly inspired us to explore new possibilities in integrating AI with the mechanical engineer. Thank you, Dr. Abhishek Kumar, sir, for your valuable presence and impactful presentation. On behalf of organizing committee, I myself, Dr. Mohammad Asif Katimani, as a coordinator, I thanks for your insightful presentation. On behalf of Department of Mechanical